Jai Hind students, this is the next lecture in the series of satellite communication subject, and today we are going to discuss how we can find the orbital elements for the satellites. As per the previous discussion, I told you about that satellite is always located in the orbit, and to find out the exact location or to locate any satellite in the space, we consider three concepts. In first concept, we are locating the satellite into the orbit with the help of the orbital parameters. In the second, we are locating the satellite in its orbit with respect to the space. Means if anyone or any other spacecraft or any other astronaut who is present in the open space, and if he wants to locate the satellite in its orbit, then there is another procedure which we discussed in the previous one. Now talking about the third one, today we are locating the satellite with respect to the earth, because the main use of the satellite is always governed by the earth station, and it is required for the earth station to locate the satellite in its orbit so that proper communication can be maintained between the earth station and the satellite. So this is about the locating the satellite with respect to earth. In this diagram you can see that we are using a geocentric equatorial system, and in this system actually we are locating the satellite by using some specific parameters that are called orbital parameters or orbital elements. Actually this geocentric system differ from that shown in only in that there are xi axis point to the, that is the xi axis, and this xi axis actually point towards the first point of the Aries. So here question arises that what is the first point of Aries? Basically the first point of Aries is the direction of the line from the center of the earth through the center of the sun at the vernal equinox. The vernal equinox time is the 20 or 21st March in the northern hemisphere. So the instant when the subsolar point crosses the equator from south to north, in that above system an object may be located by its right ascension and the declination. So basically in this geocentric equatorial system we are actually using 3 points, and the one point is very important which make the difference between this geocentric equatorial system and the other one, that it is using a xi axis which is pointing toward the first point of Aries. Also they are using right ascension, this one, and the declination angle by in this particular coordinate system. So now going towards this the further example, actually in this locating the satellite with respect to earth, actually they are deriving these 6 orbital elements. These 6 orbital elements are eccentricity, semi-major axis, right ascension or ascending node, inclination, argument of perigee, and time of perigee passes. Actually all these elements are derived from the space orbit. Actually in the last lecture of orbital mechanics, I derived a equation of satellite orbit which was a second order differential equation, and when we solve that second order differential equation we will find these orbital elements that can be helpful to locate the satellite with respect to the earth. So here you can see that this is the axis xi, yi and zi. Zi is the earth rotation axis, whether this is the satellite orbit, this is the perigee point, this is the actually argument of perigee, that one is the inclination, this is the ascending node. Basically when we are talking about the satellite orbit, actually satellite orbit and the equatorial orbit are intersecting on a specific point. So that point when we are combining that point, then we are getting 2 nodes, and that nodes are ascending node and descending node. So basically when we want to describe these ascending node and descending node, actually when the satellite moves from north to south, that will give the ascending node. Similarly, descending node, when it comes from south to north, that is descending node. So basically these are both are the nodes, and the line connecting between those are the line of nodes that we will discuss later in this series. So these all are the orbital parameters or orbital elements which are required to locate the satellite into the space with respect to the earth. So now one by one, how we can understand these points? First of all, eccentricity. Actually, you know that as per the Kepler's first law, all satellites are orbiting around the larger body in an elliptical path, in which the larger body is located on one of the foci of this ellipse. So when we are talking about ellipse, so we have to know the geometry of the ellipse. Basically, ellipse is made by making a cross section on a conical surface. So when we cut down the conical surface on a particular angle, that will give us various kind of we can say that geometrical shapes. When it is 0, then it will give a circle. Then if we making a inclination angle, then it make a ellipse. When that angle is more than a range, then it will become a parabola, and for the higher angles, that will make a hyperbola. So basically in this diagram we are actually talking only about the eccentricity and the semi-major axis. So you can find out these points from here. So eccentricity is actually the measure of you can say that the information about taking the information about the orbit, that which type of orbit we are using for. As if you are taking a geostationary satellite, then the orbit is a circle. It means the value of the eccentricity E is equal to 0 there. But if that E is equal to 1, it means that is a hyperbola. Because of that hyperbola, that orbit will become a deep space mission orbit. But when we are talking about the satellites, that eccentricity will be between 0 to 1. That's why this is we are talking about this. So now also we required this definition. Actually, periapsis and apoapsis, or perigee and apogee, these both are the same, but actually we are using the perigee and apogee here mostly, because perigee and apogee are described as, the perigee is a point which is the closest point of the satellite orbit with the respect to the earth, that is the perigee, and the farthest point from the earth is known as apogee. Similarly, when we are talking about the same definition for the periapsis or apoapsis, means when we are describing the same you can say that the same location with respect to sun, means when you are making the nearest and farthest point with respect to sun, then it periapsis and apoapsis. When you are talking about perigee and apogee, it is with respect to the earth. So in this diagram you can see that it is the sun, and nearest point of the orbit towards the sun, that is the periapsis, and farthest is apoapsis. But when we are talking about the earth, that is the earth, nearest point is perigee and farthest point is apogee. So this is both about the same points, but the only with respect to it changing. So semi-major axis. Now this is the elliptical path. So this is the longest axis and this is the smallest axis. This is the semi-minor axis and this is the semi-major axis. So you can easily identify these points, and in this case also you are talking about with respect to the earth. Then this is the total relation of eccentricity and semi-major axis, that E is equal to C by A. Actually this is the structure of the ellipse or the structure of the path of the satellite. You can see here that this is the geometry of the ellipse, in which these F1 and F2 both are the foci of this ellipse, and this is the center of the ellipse. This is the semi-minor axis, this is the minor axis, this is the major axis, and by dividing it we are getting semi-minor and semi-major, and these are the co-vertex and vertex of the this particular system, and this is the focus, or we can say that foci. So when we want to calculate the eccentricity. Basically eccentricity is C by A. C means that is the linear eccentricity we are giving us. So as per last discussion, if eccentricity value is 0, it will become a circle. That is the orbit is used for the geosatellites. Means geosatellites having a eccentricity value of 0. When we are talking about ellipse, it is between 0 to 1. And then when we are talking about parabola, that is 1, that is in infinity. Basically these parabola and hyperbola orbits are used for the deep space missions. Deep space missions. So this is about the eccentricity and semi-major axis. You can also more understand the eccentricity principle by this. You can see that for this circular path, eccentricity is 0. But as soon as it is going towards 1, you can see that there is a more elliptical path here. 4.2, 4.5, 0.8, 4.95. So this is the path of geosatellites, and these are the another one. Now geocentric equatorial coordinate system. Now we are talking about the remaining orbital elements. So for that you have to first identify this geocentric equatorial coordinate system. In this diagram you can see that this is the XYZ normal direction, where this is the reference direction. As I told you, point of Aries, because this is the side where vernal equinox happen towards the sun. So basically this is the vernal equinox point. Now this blue point is showing the angle between the argument of periapsis. Basically this argument of periapsis or perigee is created on the orbital plane. Actually you can see that here, this plane, that grey plane, this grey plane is the equatorial plane. Equatorial plane. Whether this yellow is the orbital plane, means the satellite is orbiting in this point, and the point where this cross section is happening, this is the point of line of nodes, because it is creating two nodes. These are the nodes. Now this is the ascending node, this is the descending node. Here the celestial body or the satellite is be placed. Now this is the true anomaly. This red is the true anomaly, which we will discuss later. This is the true anomaly. This is the longitude of the ascending node. This is the ascending node. Now this is the angle of inclination. Inclination means the angle formed between the equatorial plane and the orbital plane. And the argument of periapsis is basically related to the perigee, or periapsis is the same. So now this is the inclination angle. By this diagram you can easily understand this. This is the earth, this is the equatorial plane. Now this red part is that is the actually orbital plane. Now for the inclination angle you can see that here 45 degree is the inclination angle, and that point which is going, that is prograde. Prograde means direct. You are moving from south to north. But now when we are talking about this, in this we are for that is retrograde direction, and this is the inclination. So this is the 90 degree angle. So you can see that all that points we are having various angles. So similarly this is the right ascension of the ascending node. Here you can see that this is the ascending node, this is the line point joining line of nodes, and this is the vernal equinox direction, means towards the sun, xi axis, and this is on the orbital plane, equatorial plane. This is the orbital plane, and ascending node and descending node. So now this is the right ascension of the ascending node. You can see here the red part. Again it is going to show that you can see that ascending point is from where satellite is moving towards the north from the south, but in the descending node it is moving towards the from the north to the south. So these are also giving. Now this with respect to the vernal equinox, this is the right ascension. Similarly argument of perigee. Argument of perigee is omega. You can see here it is starting from the here and it is ending on the perigee point. So this is the argument of the perigee. Similarly the locating the satellite with respect to the earth, we have to define such some specific definition always, because these all are going to help you to locate the satellite in the orbit. So first one is the epoch. Epoch is the specific time at which the position of a satellite is specified. Means here, if the satellite is here, this is the epoch. If it is here, this is the epoch. Similarly, eccentricity E, that I already told you, half of the distance between the foci of an ellipse divided by the semi-major axis. Think of it as a measure of how out of round an ellipse is, and eccentricity of 0 would be circle. Means if you want to define that how much roundness is there in the shape of the ellipse, that is going to be decided by E, and it is by giving by C by A, where A is the semi-major axis and the C is the divided by the distance between the foci of an ellipse. Now perigee or perihelion, that perihelion is basically there are three words: perigee, perihelion and periapsis. Periapsis. When we are talking about these, perigee is with respect to the earth, periapsis is with respect to sun, perihelion is with respect to any body, any object in the located in the space. So the point in an orbit when the satellite is closest to the earth, means earth for perigee, perihelion or periapsis, sun or outer side objects. Similarly, apogee, point in the orbit when the satellite is farthest from the earth or sun, apogee or aphelion. So these are the points. Now period. Period, basically the time it takes the satellite to complete the orbit. Means here the satellite is moving. If it is completing, means from starting from ascending node to coming again to the ascending node, the time taken by the satellite, that is the period. So now semi-major axis A, the half of the longer of the two axes of the orbit. This is the ellipse. These are the two axes, long one, short one, minor axis, major axis. Half of this, that is semi-major axis A. Half of this minor axis is semi-minor axis B. So after both of these, we are going to describe this mean anomaly. Mean anomaly compared to the true anomaly, the angle that a satellite would have moved since last passing perigee or perihelion, assuming that the satellite moved at a constant speed in an orbit on a circle of the same area as the actual orbit ellipse, and it is equal to the true anomaly at perigee and apogee only for elliptical orbit or at all times for circular orbit. Means if you want to see here in this diagram, this is the true anomaly, and on the other points it is making the mean anomaly. So now true anomaly, the actual angle that a satellite has moved since last passing perigee, means the xi axis is from the center of the earth toward a fixed location in space is called first point of Eris, that I already told you in the previous one. And actually first point of Eris is always coming from the vernal equinox, and the xi and yi, because that xi and yi location are actually, that plane contains the earth equator and is called the equatorial plane. Means this is the xyz direction. So this is xi or yi, or that is zi. That plane is called equatorial plane. Now angular distance measured eastward in the equatorial plane from the xi side. This is the xi, actually this is the xi axis. From this xi axis you are taking the measurement in the eastward direction. This is the direction, eastward direction. In this direction you are taking the right ascension, and give it is the symbol right ascension. And as I told you in this previous diagram, that you can see here, right ascension. Here, right ascension. Now going towards the next one, the 2 point at which the orbital penetrate the equatorial plane are called nodes, as I show you in this. This is the equatorial plane, this is the orbital plane crossing these points, these are the nodes. So, 2 points at which the orbit penetrates the equatorial plane are called nodes. The satellite move upward from north towards the north through the equatorial plane at the ascending node, and descending node means downward, means south towards the south from the north. So, these are the points. Now, right ascension of the ascending node. Another term for longitude of the ascending node, it is the angle of the ascending node measured in east direction of the vernal equinox along the equatorial plane. So, it is also very important. Now, argument of perigee. Argument of perigee is the angle between the ascending node and the perigee, measured counterclockwise along the plane of the orbit. You can see here, counterclockwise. So, this is the argument of perigee. 9. Time of perigee or time of perigee passes. The time at which satellite last passes perigee. That is the time of perigee passes. Similarly, in inclination. Inclination is actually the angle between the plane of the orbit and the plane of the celestial equator or the earth orbiting satellites, or the plane of the elliptical of the sun orbiting satellites. Means, in this diagram you can see that this is the xy axis, this is the equatorial plane. On the angle I there is a another orbit, and that orbit and between that the angle is known as angle of inclination. So, in this lecture we basically concentrate on the orbital elements. In the next we are going to discuss the various derivation related to these things. So, thank you till then.